What I want to do, again, as Jeff said, follow up on Tuesday's talk, which was more of an introduction just to concept mapping generally, is to talk a bit about what we're doing with our concept mapping learning assessment tool, Sero. And what I want to sort of base this in, loosely base it in the NAEP science framework. That's one of the things that inspired us to go down this path of developing Sero. And talk to you a bit about how we've done it and some of the advantages and disadvantages thereof. I think you all know me by now, co-host of the conference, President Sero Learning Assessments, and our book, Applied Concept Mapping, which I wrote with, edited with Joe Novak and others. So for those who weren't here Tuesday, just a brief update on the talk from Tuesday to talk about what are concept maps. If you've never seen a concept map, this is what it looks like. You'll notice that the concept map itself answers a focus question, and I'll come back to this notion of focus question. But if we have a focus question, for instance, of how do molecules build the world, here's a pretty basic concept map. The key features are the concepts, the linking phrases that connect those concepts to other concepts, and the arrowheads that show how that concept, linking phrase, concept, or proposition should be read. It's basically a hierarchy. It's not a strict hierarchy because we have things like cross-links. So those key features of concept mapping are actually what we use in order to introduce concept mapping as an assessment. Keep all these features in mind because you're going to see them later. Building up these organized sets of propositions then allows us to create concept maps, which are meaningful diagrams of mental models. Back to the focus question, talked about this a bit on Tuesday. So there are evidence-based differences between what sort of concept maps people might develop given a focus question that's either static or dynamic. In this case, this example, what are the parts of the solar system? You might expect the parts to comprise the map, whereas a more dynamic question, how do parts of the solar system affect life on Earth? You would expect a more interactive set of propositions that talk about how these different parts of the solar system affect parts of the Earth. Propositions, as I said, were this concept, linking phrase, concept, that differentiates concept mapping from other diagramming tools like mind maps, where the linking phrase is not specified. We also, in particular with Sero, are explicit about this arrowhead in the proposition. So that tells somebody which direction to read the proposition. So Earth revolves around the sun creates a true proposition, whereas if that arrowhead was going the other way, that would be a false proposition. So I want to switch out of Sero talk and look at the NAEP science framework, in particular how it recommends and has recommended actually for quite some time that concept mapping be used as an assessment item. So if we go over to the, I got to get my bar out of the way. There we go. If we just take a look at the NAEP framework for science, this is a national level assessment and grades 4, 8, and 12. And the National Assessment of Educational Progress, the science framework, includes concept mapping as an interactive computer task. I just excerpted from the NAEP some of the pieces of the framework which talk about concept mapping. It is described again as an interactive computer task, even suggests sort of what the task might look like. Obviously, this is a bit of an older view of tools, but the concept's the same. And so the idea is that a focus question can be given. You can provide the concepts and the linking labels or not. That's kind of an optional piece. And then more description about how this can be set up, how it can be scored, is given in the framework. The other place that the concept mapping appears is in the specifications. This goes back to 2009, and it's my understanding that, at least for the concept mapping piece, this is the most recent version of the specification. And so, again, described in terms of what concept maps provide in terms of their value, and then how you can set them up. So here's another Representation, again, the idea is pretty much the same, concepts and linking phrases, with the task being to provide the concepts and linking phrases or some combination thereof for the students to create a concept map from content given. There is in here also a description of a task where the concept map is only provided in terms of the concepts, and then the students can create their map from those concepts by creating the hierarchical or not always hierarchical view of the propositions, but add their own linking phrases. So even within the NAEP, you can see a couple of different iterations on how this can be done. And as you can also see, if you read closely, this is an evidence-based practice. So this research in doing this sort of thing has been around for 30, 40 years. And the NAEP is, to my knowledge, the best place where using concept mapping as an assessment strategy, in this case for a national assessment, has been specified to this level. So that's what the NAEP has suggested. Again, to my knowledge, you doing this sort of thing has not been pilot tested, although some of the other interactive computer tasks have been pilot tested. And so when this first came out in the NAEP, we got inspired to sort of go down this path of developing our tool, Sero, to implement this approach, but also to think more broadly about how we could use concept mapping not only at the national level for assessment, but bring it into the classroom so that teachers can make more efficient use of concept mapping. That efficiency factor has been one of the reasons why concept mapping is not used more broadly. While we know that it's used in pre-K all the way up through adult learning, and it's used all over the world, we see that in pockets. And so we don't see sort of broad implementation of concept mapping. And so with the NAEP calling for this approach, and with that efficiency factor being a challenge, we've gone down the road of developing Sero, which is our tool. We've developed Sero through a series of Department of Defense grants, actually. Department of Defense is very interested in learning and learning assessment and e-assessment, and in using these types of tools to not only assess learning, but also to assess how teams work, and then to even drive further to think about how we can perhaps automatically or semi-automatically generate assessments. And so that's our current work with the Army Research Institute, is to try to add even more efficiency to the process in terms of authoring the maps. So what I want to do now is go to the live demo and show you how Sero works. I'm going to first show you from the student perspective what this sort of thing looks like. And I actually, I'm going to use the same, one of the example maps that we see in the NAEP in order to demonstrate how to do this. So what you're looking at is what the student would see in terms of the task. And we start off by scaffolding the student to show them how Sero works and how they can create the maps using this, what we call our build-a-map approach, which is essentially that these students are provided the concepts and the linking phrases, and it's up to them to form those propositions and build out the map. This idea of scaffolding the students on the task is really important to us, because if you think about it, students are very used to doing multiple choice tests or true and false tests, or even older students used to writing essays and maybe even building portfolios. Doing this kind of assessment, though, is going to be new to most students. And that's always been in the back of our head as we've been thinking about deploying this at a national level, is how you actually can show students how to do the task. That scaffolding is a big part of what they'll need. So this is what students are presented with. Again, a set of concepts and a set of linking phrases. And we have tried to make this as easy as we can in terms of doing the task. So it's essentially and I'm just going to put together a couple propositions. I could go back and cheat, I guess, using the map here. Let's see, molecules can be water. So I'll make a couple that are true as well. But again, what we're trying to do is enable the students to, as simply as possible, create the map. In this case, all of the concepts and all the linking phrases should be used. I'm going to cheat again. Water can be found in living things. Water, let's see. We can allow them to change their map as well if they want to recreate a new proposition. Water is found in living things. So this is the task essentially, is to take these concepts, these linking phrases, and answer the focus question. Again, we always start with that focus question. It provides the context and the bounds for the map. So this is the task that students will do with our Build-A-Map. Let me just do a couple more. Let's see, molecules have motion. And so we can allow them to build out their map. And I just want to get a couple of these right, but I'm going to leave content on the table for us to look at. We don't anticipate that students would recreate the exact structure here. I'm obviously able to see that structure, but more important to us is the propositions that they create. And so we don't restrict them in terms of where things can be put. We're much more interested in what propositions they make, what propositions they organize in order to answer that focus question. So fairly simple in terms of the execution of the task for the students. They can then submit their map. We do prompt them with, in this case, hints to show that they still have some content that's left on the table, if you will, and suggest that they might want to complete that, or we give them the option of just going forward. So in this case, they can get the immediate results, and this is essentially comparing their work to that reference map, which comprises the map that I showed you from the NAEP example. Shows them instantly which ones they got correct, which ones they're missing that were in the reference map, and which ones they got incorrect. In this case, you see an incorrect one here and lots of missing ones, obviously, because I didn't do it, but the green shows them which ones they got right. If you want to use this as a more of a formative or learning assessment for learning task, you can also show them that reference map, right? So now they have to compare what they've done to that reference map. That is one of our implementations of concept mapping. It is the one that is closest to the NAEP type of deployment. We have another approach that we've been working on as well, which is what we call our skeleton maps. So this is, again, another way to use concept mapping for assessment. In this case, what we're doing is taking that reference map and adding what we call assessment items. We have 6 different kinds of assessment items, and these are essentially taking the concept mapping process down to its elemental level and using those elemental tasks to create an assessment. So again, scaffolding the learner in terms of what they'll need to do to execute this kind of task. We have 6 different kinds. We have what we call our multiple choice item, which is select a node within the graph or a concept or linking phrase and get options for what should be filled in there. We have one that's a fill-in, which is a recall task as opposed to multiple choice, which is more of a recognition task. The fill-in suggests that they put their own content in. We have what we call a drag and drop. This takes items from outside the map and moves them in and where the learner needs to connect them in a particular place. We have an error correct item, which was inspired by some work down at the University of Sao Paulo in Brazil by our friend Paulo Carrillo and his colleagues. And this introduces errors into the map and suggests that the students try to find them and correct them. We have another one, which is our connect to, where you're making those connections between concepts and linking phrases or linking phrases and concepts. And then we have our arrowhead direction, where you're determining which direction that arrowhead should point. Again, these are all just basic elements of the concept mapping process that we've now turned into a way for the student to use some content and structure that's provided to them, and then also introduce their own. So the way that this looks then, let me move my Zoom bar out of the way, is, again, here's our multiple choice item. Molecules can be water. I know that one's correct. Water can change. Here's a connect to item. We can connect anywhere in the map. We'll just connect here because I think water can change to liquid. Here's a fill-in item. The student now is to recall right? And so this is not giving them students content. They need to recall the content and figure out what needs to go here. If I recall correctly, that was molecules. Oh, no, not molecules. Let's just say things. We'll fill that in. Here's our arrowhead direction. Again, the student needs to determine which way this arrowhead should point in order to make a true proposition. These are our drag and drop items. And so students can bring in the items and figure out where they should appear in the map in order to make true propositions. And lastly, you'll notice there's one more item, our error correct item. It is not visually cued, but it is cued instead by the content of the proposition. Water only sometimes found in living things. Water is found in living things. So they find that proposition, which is incorrect, and they change it. Again, we prompt for any unanswered work. And again, immediate feedback. So the students are shown which ones they got, which one's correct and which ones they got incorrect. And then we do show them the reference map as well. So those are our two implementations. Again, the Build-A-Map and the skeleton map, with the Build-A-Map being closer to what the NAEP is called for. But our skeleton map gives a lot of flexibility in terms of creating interesting, engaging assessment tasks in a concept mapping format. We can vary the difficulty of the maps quite a bit, depending on the content of the map, the size of the map. In the case of the skeleton map, also vary by the kinds of assessment items that we introduce, and how many we introduce, what the distractors are. So whereas the last presentation was really focused on the content of the assessment, we're also focused on the structure of the assessment. You're no longer looking at an assessment comprising a series of linear questions, which very often don't have anything to do with each other. You're now in the space of providing a much more holistic evaluation and assessment of not only what the student knows, but also enabling that assessor to look across the students to see where the misconceptions lie, what sort of trends exist in the mental models across the students, in order to teach from that point, which is really a goal of concept mapping, is to ascertain what the students know and then teach from that point. I want to quickly show you, that was the student side. I want to quickly show you the teacher side of Sero, just to show you what this looks like on the other side. And I want to first show you what the results look like. This is going to be looking at a different map, which is about matter. And so what we can see is that we're able to now look at these maps and assess them and evaluate them on a couple of different levels. So the first level we can look at is across everybody, all the students. We can see what propositions generally the students got right, which ones they generally got wrong. We can, of course, then look at each individual student to see their results. But if we look at it from the meta level, if you will, the amalgamated view, we can now see consensus in terms of which propositions students are getting more right, and which ones fewer students are getting right. And so this gives us a sense, again, a snapshot view across all the students. Which of these propositions do they seem to know and know pretty clearly, and which ones are they still struggling with? We can also, again, this is the Build-A-Map task, because we're looking across all the students using the same components, or as I sometimes refer to them, Lego pieces. Because everybody's using the same components, we can now compare the students also to each other and give various views which indicate not only each individual student, but we can now show how close is each individual student to that master map, but also how close are they to each other. And so we can compare the students by looking again at the propositional level to show which ones they got in common with one another, and which ones they don't have in common. We see then in the sort of the bullseye chart here, then clusters of students. In this case, the example has 7 students, but you can imagine as the numbers get larger, those clusters start to take shape. So that is what this looks like from a review perspective. Quickly walk you through our authoring process. So how do molecules, again, starting with that focus question, which provides the context, molecules work. We have an option to do the scoring approach if you want to compare the students' work to your reference map. We also have some options for just providing lists of concepts if you want them to develop their own. Those, of course, we aren't yet evaluating because the students are now introducing their own content, their own Legos, if you will. So those are harder to score, but they can provide a different kind of activity for offering this kind of approach. And so we'll do a scored here. We have a number of ways that we start the reference map building from. We can start from scratch. You can build on a prior assessment. You can use files from other concept mapping programs. In this case, I'll just pull up the one from before. Here you can edit the map. We've also been introducing some automated tools to implement what we know to be good practice for concept maps. So for instance, our structure tool here is going to point out that here's a cross-link. We know that cross-links are very good and encourage meaningful learning. So this is a good thing. We can also point out where the structure itself might have some things like fans, which are a lot of concepts that come off a single linking phrase. And the goal here is to provide guidance. It's not to automate the authoring process in terms of structure or content. It's to embed these rules of thumb about what we know good concept maps comprise. So we have a couple of tools to help that process. And then moving forward, you decide at this point whether you want to do the build a map, so give the students just concepts and linking phrases, or you want to give them a skeleton map. In this case, we also have another automated tool that allows us to have Sero look at the content, look at the structure, and suggest to you where assessment items might appear and which kinds of assessment items you might want to use. This is a huge advancement for us under our Army Research Institute work. Again, trying to get this authoring process as efficient as possible, because we're sensitive to this is a new thing. It goes way beyond multiple choice. And we realize that if we want folks to try to implement this in the classroom, we need to scaffold them with additional tools that make setting up these kinds of assessments as easy as possible. So that's a quick demo of how Sero works. Again, what we're trying to do is play within the space between giving students instruction and training them on how to create good concept maps, and then having them start from scratch, which is very insightful if you can get up that very steep hill of onboarding them, of giving them the kind of feedback and training to create good concept mapping skills. We know that creating the maps from scratch is incredibly insightful, but we also know that they're harder to evaluate, because if you have 30, 40, 50 students, you're going to get 30, 40, 50 different concept maps. And so the trade-off is between that and in the other upper right quadrant, giving them everything, right? Giving them an entire map to read, or giving them a lot of the content. So we're trying to play sort of in the gray space here, which is using concept mapping processes, elemental processes, as well as the overall process, like in the build a map, to build out the map, to enable these kinds of assessments to be used in the classroom and at national level assessment scale. So it's a big elephant, and we're trying to cover a lot of ground here with Sero. We have a pretty mature capability to do that, but we're continuing to build. I mentioned earlier our current work with the Army Research Institute, which is focused in part on those automated support structures that I showed you, but also to try to use natural language processing to go from text into a draft concept map that the authors can then revise and turn into the kinds of map that they want to use. We've also looking at other tools, for instance, notating and highlighting tools that would allow them to quickly capture some content and get it in the map. Again, I appreciate what Ian said the other day about efficiency, but to do something of this scale and to try to introduce something as different and unique as this approach is going to take some attention to the efficiency factor. So we continue to build in some automated support for the authoring piece. We're also very interested in and have for a long time been interested in what we can call telemetry data, which is each and every action those students take. So in our skeleton map, we can think about the sequence of items, which items they answer first, which items they go back and change. And for the build a map, we can think about which propositions they're forming first, which ones they break up and reform. We're enabled to do this through XAPI, which has already been mentioned here a couple of times at the conference. XAPI enables us to track each and every one of those actions. Our goal now is to do something with those data. And as you can imagine, that's voluminous data, even for a small assessment, but it really has the potential to show us trends, to show us patterns that students take through the assessments, and at a much larger scale. You can imagine those patterns enabling a lot of inferencing about what students think and how they're thinking about it. I'll close with an invitation. Everyone, of course, is welcome to register for a free Sero account. We've put a number of learning journey resources for teachers and for students, again, to sort of walk down this path of concept mapping, what it's all about. And we're very interested in continuing to engage with folks through our pilot program. Come, let us help you set up, let us engage with you to figure out how this kind of approach might work in your classrooms, in your schools, in your districts. And with that, I will close up. I invite everybody to connect with us on Twitter and also LinkedIn. And Jeff, I hope I've gotten us a bit back on track on time.
Yes. Thank you ever so much, Brian. Brian's going to be busy today. He's also chairing the session this afternoon. He's done the demonstration. He'll be chairing the next session. And he's our puppet master behind the scenes, keeping all of this iceberg of a conference afloat. So I'm just going to give him 30 seconds to catch his breath before moving on to the next session, and invite you to please have a look at the concept mapping. It is breathtakingly clever idea, if I may say so, and it's one of those areas that I think is where the future of assessment lies.